Okay, now I want to talk about some of the ways people have come up with to decide that they're looking at something that really is a causal relationship and not just an association. You should have done the reading at this point, which talks about the attempts to show that lung cancer really is caused by smoking. And that historically really is when people started thinking about causation beyond the sort of necessary cause germs that cause flu sorts of questions. So you also should have looked over Bradford Hill's essay in which he lays out a series of things to look for when trying to argue that you have a causal relationship. And that's what I want to go over with these slides in more detail. Unlike most of my other videos, I don't have a lot of questions for you. I think there's just one place where I'm going to ask you to go enter things on the form, but this feeds right into the rest of the homework where I'm going to ask you to take the causal pies, which I hope you've already looked at, and think about them using Bradford Hill's causation language. So slightly different this time. Let me share my screen, and there we go. So we're talking about the attempts to decide whether we have an association or true causation and how we get at that. So here's an important example that actually we're going to learn more about later, which is looking at cholera deaths in England in 1849. This is part of a very famous story that is credited with really the founding of epidemiology. There were these cholera outbreaks in London and people were trying to decide why they happened, what caused them. And one argument was that they were somehow caused by elevation. And you can see that this data here certainly makes it look like the lower you were, the closer to the River Thames, the more cholera deaths there were. And as it got higher, there were many, many fewer. And somebody came up with a formula that predicted mortality based on elevation. That's the dotted lines, which fits incredibly closely to the actual data. Now, it turns out that elevation is not causal. Being up high, it does not somehow magically make you much less likely to get disease. Cholera turns out to be associated to contaminated water, which was associated with poverty. And in London at that time, poorer people tended to live lower down. The hills were better places to live. So this very strong relationship was nevertheless not actually a causal one. So this is our question. If we observe a relationship between an exposure and a disease, we have a relative risk. We have an odds ratio that makes it look like there's a relationship. Is that association actually causal? What do we have to think about? Is it due to chance? That's a job of the confidence interval. Is a confidence interval go from across two different sides of one, in which case it might just be chance. If chance is unlikely, then is it due to bias? We have to think about measurement bias and selection bias. If we think we've done a pretty good job of taking care of that, then we ask about whether there were confounding factors that played a role. And there very often are, but we probably did our best to consider those. And if we think confounding factors have been pretty well taken into consideration, then we really do have an association. And we have to try to think about, is this causal? So when we've observed an association between two factors, we have to infer from what we know about the study and kind of all pertinent knowledge about whether it's really reasonable to say that this is causal. And again, cause is sort of much more a philosophical question than a truly mathematical one. And these days is really a hot topic in the fields of epidemiology before current events and statistics in general. So we have a hierarchy of primary evidence where our case reports and case series are the very lowest. Then comes the ecological studies. Those are suggestive. The cross-sectional ones, which fail to give us this time element. And then we move into the ones which are really the core for epidemiological thinking, the case control studies, which show more room for bias than the cohort studies, and the cohort studies, which leave more room for confounding factors than the randomized controlled trials. So in general, we move from the weakest types of studies here to the strongest types of studies up on top. Now, that's all mediated by a lot of other issues. We have to say, when can we do randomized controlled trials? Sometimes you can't do them ethically. Studies are not necessarily judged purely based on the type of study they are. There are badly done cohort studies and well-done case control studies. Maybe you have a cohort study that really didn't look at confounders and a case control study that did so very carefully. On top of this whole pyramid comes what we call secondary data, which is aggregations of multiple studies. We saw a little bit of that when we looked at the abortion and breast cancer story, because there that data was coming not from a single study, but from a collection of them. Actually, I'm going to stop this here and do another video for the rest of this. So I'm going to pause now. You don't actually have anything to give me feedback on, so there's no form that goes with this. The second video will have a form associated with it.